Hi everyone, welcome to S4 Sharnya Science classes. I hope you all are able to follow my videos. If it is really helpful for you, please support me by liking and sharing with your friends. If anybody still remind to subscribe my channel, then please subscribe it also.
Hi everyone, welcome to S4 Sharnya Science classes. Today we are doing the continuation of Chapter 3 Chemistry, Class 9, Atoms and Molecules. In the first session, we have learned about what you mean by atom, how that atom concept came, and what are that laws which support that atomic theory. That means atom of that Democrat, the concept of atom, how it is supporting, that we have discussed, right? Now, in this session, we are going to discuss about the atomic theory which was proposed by John Dalton and some of their postulates, how it is going and some things, right? So, directly into the topic, right? So, as we all know, after the chemical combination which will support the idea of atom concept, right? John Dalton was a scientist who proposed an atomic theory, right, which acted as an explanation of that two laws, right? You can see that the law of chemical combination, which was proposed by Lavoisier, right? And according to these laws की as an explanation, right, Dalton ने उनका atomic theory भी propose किया है. So it was actually this atomic theory, right, Dalton's atomic theory acted as an explanation of these laws. So what is Dalton's atomic theory? That we have to understand, right? So Dalton atomic theory, according to him, they told that all matter, whether it is an element, a compound, or even a mixture, consists of tiny invisible particles called as atoms. So this was the major concept of Dalton's atomic theory. We can say that according to Dalton's atomic theory, all matter, whether it is an element, it is a compound, or even a mixture, all consist of their tiny indivisible or invisible, right? That means you can say that they are actually very tiny, invisible. We cannot see that with your naked eyes, right? So invisible and indivisible particle called atoms, right? This was the first major concept of John Dalton, right? There are some other postulates of John Dalton that also we will go through, so that we will have a clear idea about what you mean by Dalton's atomic theory, right? So the major postulates of Dalton's atomic theory are: first one, he told that the matter is made up of tiny particles called atoms, right, and that cannot be divided. That was the first postulate. What was the first postulate? क्या था? The matter, right, is made up of tiny particles called atoms, and they are indivisible, right? That means we cannot be divided. They cannot be divided. We cannot cut them, right? So this was the first postulate. What was the second postulate? According to John Dalton, atoms are never formed or destroyed during a chemical reaction, right? So atoms are never formed or destroyed, right? That means we can simply say that atoms cannot be created. We can say that, right? Cannot be created or destroyed, right? Never be formed or destroyed during a chemical reaction. This was the second postulate, right? Now what was the third postulate? According to Dalton, atoms of an element exhibit same nature, right? So atoms of a given element, right, they are similar in mass and their properties, right? So we can say that atoms of an element exhibit same nature, they have the same size, same mass, same character. Sorry. So simply we can say that atoms of a given element, right, are similar in mass and properties. What about atoms of different element? Atoms of different element exhibit variant nature. That means atoms of different elements have different masses and the different properties also, right? So that also we can add here. Atoms of different elements are different in mass and properties. This was the fourth postulates, and their characters also will be really different. That means they are variant in their nature, right? The fifth point of that Dalton's atomic theory, right? Fifth postulate, we can say that that's actually atoms form compounds by combining in a special ratio. That we can say that the ratio will be in all number, right? So atom combines in a whole number ratio to form compounds, right? That was the fifth postulate. Atoms combine in small whole, it's not fraction or anything, they are telling it's whole number ratio, right? It's whole number ratio to form compounds. Now the sixth postulate was like this, right? A compound actually contains a constant number and kinds of atoms, right? So that means in a given compound the relative number and kind of the atoms are constant. They will be constant always. एक given atom, given compound दिया है, उसमें कितना number of atoms होती हैं और कौन-कौन सी type की atoms होती है, kind and the relative number of atoms, that will remain a constant, right? So we can say that a compound contain a constant number and kinds of atoms. A compound contains a constant number and kinds of atoms. So these were the major postulates of Dalton's atomic theory. Now we have discussed about Dalton's atomic theory, right? So we are going in detail of what you mean by an atom, what is the size of an atom, how it is existing, what is about their stability and all, right? So what do you mean by an atom, right? Atom, that we already learned that atom, it is the smallest indivisible, right? But हमने learn किया है actually according to Dalton, Dalton ने तो बता दिया था they are indivisible है, actually they are indivisible है क्या? It's not actually indivisible for the time being. We have already learned about the subatomic particles, right? The subatomic particles already हमने learn किया है, like electrons, protons and neutrons. इसके बारे में भी we will learn in detail. There are so many other subatomic particles like mesons are there, positrons are there. उसके बारे में हमने इतना डिटेल में नहीं learn करती है, but there are some other subatomic particles are also there, right? So now we are going to learn about what you mean by an atom correctly, right? What is their size, that we are going to learn, right? So can you say that what you mean by an atom? It's just like we can simply compare atoms as a building blocks of matter, right? तो अभी ये आपका एक मैटर है, राइट? एक मैटर है, इसका बिल्डिंग ब्लॉक, दैट मीन्स इसके छोटे छोटे, मान लो ये ब्रिक्स है, राइट? स्मॉल स्मॉल ब्लॉक्स ऑफ ब्रिक्स है, राइट? एक बिल्डिंग की दीवार वॉल बनाने के लिए यू कैन सी दैट ऐसे बहुत सारी ब्रिक्स यूज किया होगा, राइट? सो लाइक द सेम वे यू कैन सी दैट ऐसे बहुत सारी ब्रिक्स यूज किया होगा, राइट? सो वी कैन से दैट मान लो दीज आर द एटम्स, राइट? सो ऐसे ऐसे एक एक एटम, दिस आर द बिल्डिंग ब्लॉक्स, बेसिक बिल्डिंग ब्लॉक्स जिसमें से वो वॉल बना हुआ है, राइट. सो इट्स जस्ट लाइक ब्रिक्स दैट ना दे आर द बिल्डिंग ब्लॉक्स ऑफ ए बिल्डिंग, राइट. सो दैट वी कैन से दैट, राइट. सो एन एटम इज द स्मॉलेस्ट पार्टिकल ऑफ एन एलिमेंट that may or may not exist independently and retain all its chemical properties, right. So वो independently exist कर सकते हैं, नहीं तो कभी कभी independently exist नहीं कर पाती है, right, but it will have all the chemical property of that substance, right. So simply we can say that an atom, the smallest, right, particle of an element that may or may not exist independently, right, and retain all its chemical properties. So that's called an atom. Clear? Right. So what is that actually size of an atom? क्या होती है साइज की, एटम की साइज, राइट. हमने बोला था दे आर द स्मॉलेस्ट पार्टिकल. तो कैन वी सी विथ आवर नेकेड आइज? ऑब्वियसली हमने इनविजिबल पार्टिकल बोला था. तो नेकेड आइज से यू कैन नॉट सी दैट. एटम्स आर एक्सट्रीमली स्मॉल, राइट. सो दे आर वेरी वेरी स्मॉल इन साइज एंड स्मॉलर देन एनीथिंग वी कैन इवन इमेजिन और कंपेयर कर सकते हैं, राइट. उतना स्मॉल है, राइट. इफ देयर साइज इज एक्चुअली मेजर्ड इन नैनोमीटर, वी कैन से दैट व्हाट से 1 नैनोमीटर जो बोल रही है 1 नैनोमीटर, right. 1 nanometer we can see that 1 upon 109, right, meter, right, like that you can see that, right. So atomic radius mostly हम nanometer में measure कर देती है, right. You can see that, right. उतना small है, right. So simply we can say that 1 nanometer is equal to 10 raised to minus 9 meter, right. और 1 मीटर जो बोल रही है, right, it's actually 10 raised to 9 nanometer है, right. That much small. आप देख लेना, you can see that 1 upon, right, 10 raised to that now what to say 9, right. That's actually 10 raised to minus 9. तो आप देख लेना 1 2 3 4 5 6 7 8 9. तो इतना small, 1 upon इतना, that means you can see that, can you imagine that उतना small है एटम की रेडियस, राइट. सो एटम की साइज जो बता रही है एटॉमिक रेडियस हम हमेशा नैनोमीटर में एक्सप्रेस कर देती है. नैनोमीटर जो बोल रही है 1 नैनोमीटर इट्स एक्चुअली 10 raised to minus 9 मीटर है, और 1 मीटर जो बोल रही है 10 raised to 9 नैनोमीटर है. सो यू कैन ईजली अस्यूम दैट कितना स्मॉल होगा एन एटम, राइट. एटम की रेडियस कितना स्मॉल होगा, राइट. द एटॉमिक रेडियस ऑफ एन एटम ऑफ हाइड्रोजन, राइट. इफ यू आर टेलिंग दैट एटम ऑफ हाइड्रोजन बता रही है, एटम ऑफ हाइड्रोजन, right, the atomic radius will be in the range of 10 raised to minus 10 nanometer, right. अभी molecule of water बता रही है. These are the examples I have taken. Molecule of water, वाटर की मोलिक्यूल 10 raised to minus 9 नैनोमीटर की रेंज में होगा, राइट. उतना स्मॉल है, राइट. एक हीमोग्लोबिन मोलिक्यूल ले रही है, HB मोलिक्यूल ले रही है, देन इट विल बी 10 raised to minus 8 नैनोमीटर रेंज में है, राइट. सो हियर इफ़ यू आर टेकिंग, आप ग्रेन ऑफ सैंड ले रही है, राइट. ग्रेन ऑफ सैंड ये फिर भी हम देख सकते हैं उतना स्मॉल है, राइट. इट विल बी 10 raised to minus 4 नैनोमीटर रेंज में है, राइट. व्हाट अबाउट एन एंट, राइट. सो एंट की साइज जो बता रहे हैं हम 10 raised to minus 2 है, राइट. वाटरमेलन जो बोल रही है हमारा, राइट, वाटरमेलन, राइट. सो दैट्स एक्चुअली 10 raised to minus 1, राइट. दैट मीन्स 10 raised to minus 1. तो आप देख लेना एटम की साइज एक वाटरमेलन के कंपेयर करके देख लो जितना कम है, right. Now I think you have a clear idea about what is the size of an atom, right. Now you have to learn that अभी हमने size of an atom relative size तो बता दिया था, right. Relative size why we are telling, so that we will have a somewhat that na comparison, so that relative idea जो हमको मिलने के लिए, right. Now we have to learn about that what are the symbols, right, how we can represent an atom, right, of different elements. Elements तो हमने learn किया है that a pure substance, right. तो there are some symbols we are commonly using, right, symbols, right, to represent different atoms, right. In olden days there were some special symbols like this. If we are using the symbols, right, so these are the symbols that were used to represent different atom. If this is the symbol, this is means it is hydrogen atom, right. And carbon के लिए इन्होंने ऐसे एक symbol use किया था in the olden days. Oxygens are like this, oxygen, right. And if it is like this symbol है, इसका मतलब phosphorus है, right. And आपने ऐसे symbol use किया, इसका sulfur है, right. एक इसके अंदर I use कर रहे हैं, then it is iron और iron, right. अभी C use किया तो copper है, right. L use किया तो lead था, right. Even S use किया है तो it was silver. There was these all symbols are not at all used for the time being. These symbols were proposed by Dalton itself, right. अभी ये ज़माने में हम ये symbols use नहीं करती है, right. There are some what is say very that ना interesting symbols like that. आपने ऐसे कोई symbols बना रही है तो इसकी मतलब it is a symbol of mercury है, right. Mercury, right. Nowadays we are not at all using all these symbols. We have another symbols, right. So that means worldwide accepted symbols hai, right. So these symbols of elements which were represented by one letter, and the symbol of elements are represented by sometimes two letter like that, right. So here you can see that we are actually these letter format में जो symbols है, that's actually most accepted format for the time being. These symbols आजकल किधर भी नहीं use कर देती है, and these symbols were actually proposed by Dalton itself, right. The symbols for representing an atom are generated from the first two letters of the element's name, right. First two letters से हमने बना हुआ है आजकल जो use करने वाला, उसमें से first letter always will be in the upper case, that we can say that in the capital letter, and second letter जो बता रही है वो mostly lower case में smaller case में use करेगा. That's a symbol we are using for the time being, right. So we will go for some of such symbols. You can see that here I am representing, right. If the element, right, and what is their symbol. In your textbook it's clearly given, so I'm not going to represent all the elements and all. I just give you some examples here. If it is aluminium, right, aluminium hai, so we will represent as we told, the first letter must be in capital letter and the second must be in small letter, right. Aluminium, Al, right. What about argon? Argon, which is an inert gas, Ar. You can see here copper, for copper, Cu, right. And you can see that bromine, the first letter capital, small letter second one, right. What about chlorine? Chlorine hai Cl, right. And you can see that some letters, even you can see that fluorine, right. Fluorine, actually you can see that only capital letter F we are using, right. If it is nitrogen, then it is N. Oxygen hai to simply O, right. And you can see that what to say zinc, then it is Zn, so etc. There are so many in your textbook, it's clearly given, so you can easily understand what are there, right. So you have to understand their names, that not the symbol and everything properly, right. I hope you have a clear idea about this. In the next class we will go and discuss about the atomic mass and all these things in detail. Thank you all. I hope you understand it clearly.
Hope you all understood this video. Thanks for watching. Have a nice day.